discussion on integration of inverse trigonometric function involving secant. For our first example, solve for the integral of dx over x times the square root of quantity x squared minus 25. Now we will solve for the values of u and a. Let u squared equal to x squared and a squared equal to 25. So taking the square root of both sides, we now have u is equal to x and a is equal to 5. Taking the derivative of u, which is du, is equal to dx. So applying the variable in our original equation, our integral now will become integral of du over u multiplied by the square root of u squared minus 25. So this integral is equivalent to 1 over a secant inverse of u over a plus c. So substituting the values for u and a, the integral now is 1 over 5 multiplied by secant inverse of x over 5 plus c. For our next example, solve for the integral of dx over 6x multiplied by the square root of quantity 9x squared minus 49. Let's now solve for the values of u and a. So let u squared is equal to 9x squared and a squared is equal to 49. So taking the square root of both sides, we now have u is equal to 3x and a is equal to 7. So taking the derivative of u, so du is equal to 3 dx, dividing both sides by 3, 1/3 du is equal to dx. Okay? So our integral now is equal to the integral of 1/3 du over, since 6x is divisible by 3, we factor out 2. 2 multiplied by 3x multiplied by the square root of 9x squared is u squared minus a squared. So simplifying this, we now have 1 over 6 multiplied by the integral of du over u multiplied by the square root of u squared minus a squared. So our indefinite integral now will become 1 over 6 multiplied by 1 over a secant inverse of u over a plus c. So substituting the values for u and a, it will now become 1 over 6 times 1 over 7 is 42. 1 over 42 secant inverse of 3x over 7 plus c. Our next example is the integral of dx over the quantity of 9x minus 6 multiplied by the square root of quantity 9x squared minus 12x minus 32. For this kind of integral, first we need to make our integral in the form of u squared minus e squared. So we will be applying completing the square method. Since we have 9x squared minus 12x minus 32. So we will divide that middle term by 2 and square. So this will become negative 12 over 2 quantity squared, and this will give us 36. So we will add and subtract 36. So 9x squared minus 12x minus 32 plus 36 minus 36. And this portion will become 9x squared minus 12x plus 4 quantity minus 36. So simplifying this equation, it will give us 3x minus 2 squared minus 36. And this will become our u squared minus a squared. We will now rewrite our integral. So the integral of dx over, factoring out 3, this will give us 3 multiplied by 3x minus 2 multiplied by the square root of 3x minus 2 quantity squared minus 36. We will now solve for the values of u and a. So, we let u squared equal to quantity 3x minus 2 quantity squared, and a squared is equal to 36. So, taking the square root of both sides, we will have u is equal to 3x minus 2 and a is equal to 6. Taking the derivative of u, du is equal to 3 dx. Dividing both sides by 3, 1/3 du is equal to dx. So our equation now will become the integral of 1/3 du over 3 multiplied by u square root of u squared minus a squared. And this is equal to 1 over 9 multiplied by the integral of du over u multiplied by the square root of u squared minus a squared. So the form of the integral is equal to the inverse trigonometric function of secant. So this will become 1 over 9 times 1 over a secant inverse of u over a plus c. Substituting the values for u and a, this will become 1 over 9 times 1 over 6 secant inverse of 3x minus 2 over 6 plus c. So this will now become 1 over 54 secant inverse of 3x minus 2 all over 6 plus c.